Hello. Welcome in my tiny little mathematical channel. I am a Polish teacher, so most of my videos are Polish, but from time to time I like to do something in English because I just love this language. I love English, and I also teach mathematics in English. So this video will be in English, and it will be about trigonometric equations. This is quite difficult topic in Polish high school. This is not obligatory. So this topic is for students who want to learn more and who wants to pass math exam in higher level. So then they need to know a little bit about trigonometry equations. So I will show you today like 2 or 3 examples. We'll see how much I manage in time. I don't want to make this movie too long, so I think about 2 or 3 examples. I will show you how to solve trigonometric equations by using functions. So what I mean that I want you to use the trigonometric functions. Trigonometric functions. So I mean about sine x, cosine x, tangent x, eventually cotangent, but we can stick to these 3. So let's start with the first very simple equation, and then I'll show you what I mean by using these functions. So let's say that we have an equation like this. Sine x equals to 1/2. Very simple, right? So what do we need to do here? So we need to find all axes, right? All axes which are real numbers, but those axes which sine x is 1/2. So which are they? Because there are really a lot of them. So if we go to the next page, then you can see this is a function sine x, right? This is sine x, and this is very important function, especially in physics, when you want to talk about waves, right? Waves, all kind of waves, like water waves, sound waves. You can have light waves, right? So we have waves all around us, and you need those functions. You need sine x, you need cosine x, and tangent. Well, sine and cosine is enough. So let's take a look at this function. So this is how sine x looks. And I hope you know these little letters. If you don't know what pi means in terms of angles, you have to just look it up, because there's no much time for me now to describe it. But this is another way to describe angles. So you can describe angles with degrees. So like you can have 180 degrees, but it's the same as a pi. So basically here you have 180, here you have 90 degrees, here you have 270, here you have 360, and so on. So you have to learn this scale to be able to read this function. And then why the speed is totally another story. So I will not explain it right here in this video. So just let's take a look at this function. So what can we read here? So we know that for pi over 2, so it is 90 degrees, we have 1, right? For 0 is 0. Then you can see that here we have exactly half. I hope you can see that. Right, let me draw another circle. And here we have 1/2. And we can easily read here that here we have pi over 6, which is 30 degrees. 30 degrees, 60 degrees, 90 degrees, or 45 degrees. There are very special angles, and I hope you know them. We should know them to be able to solve trigonometric equations. So these angles are very important, and you should know what sine of 30 is, or cosine, and the other angles. So this is pi over 6, this is pi over 4, and this is pi over 3. Right? Okay, so we really need those angles. And then you can see exactly that here is something like, which has also 1/2. And we can easily calculate this angle, because if you take a good look here, it's exactly the same length. So it is pi minus, right? So if I put like this, so this is pi minus pi over 6. So there we have 5/6 pi, or you can write it down as 5 pi over 6, right? It's exactly the same. So we have two points which are exactly at the height of 1/2. Then, of course, look here. If we go over like beyond 2 pi, then you have another one and another one. And of course, this is a wave, so it goes on and on forever. So you will get, you know, as many as you can imagine numbers here. So infinite number of points. Of course, on the left side, you always have you have also another point. So what I want to say now, let me just clean here a little bit the board, because we need some space here. So right, okay, and so this is 5/6 pi. And then if you have this kind of equation, like sine x is 1/2. So what do you need to do? You have to find well, now is a good question. Do I need to find all this infinite number of points? Of course not. But if we look at the function, then you can see that it is how do you say that in English? Let me just think a little bit. I don't remember the word. In Polish is okresowa. I think it's periodic function. So there's a period of the function, and it's exactly 2 pi. And this is period of the function because then you have exactly the same situation. So we have this wave, then exactly the same wave. So you need to find the points really only between 0 and 2 pi. And if we find these 2 points, so we know it is 5/6, right, the first point, and the second point is 5/6 pi. And the only thing that you need to do here, you have to add here this period. So you need to add 2 pi, but not only 2 pi, because you can add 4 pi, 6 pi's, right? So you need to add k, number k, where number k is an integer. So we use a big letter z. So k is integer, right? And that's it. So this equation gives you gives you infinite answers, but you can write them in this mode, right? So we have 5/6, so exactly this point. This is number 1, let's say. This is number 2, and there you go. And then we add period, and we have the answer. So I like to use the functions for trigonometric equations. You can also use a circle. You can find many YouTube videos where people solve trigonometric equations by using circle. It is so-called unit circle. So then you have circle, and you divide it into 4, and you just go here through, you just draw angles here. So like, for example, I had 5 pi over 6, so it's like here, pi over 6, and then you just look at this is another one, and this is another one, and this is another one, and You can use this kind of circle to find these angles also, but I prefer the function much more than the circle. If you, maybe you should try and see the circle, and if it's better for you, then use a circle, but I like to use function like this. Okay, so let's go and see another one. So let's say that we have cosine x. Let's use cosine. Cosine x plus 1 is 0. Very simple equation, right? There you go, we have equation. And what can we do here? So, of course, I will take the one to the right side, so it's negative 1. And now I have to look for x's which have cosine equals to negative 1. So, let's see the function. Let me just come here for a minute because I need to find my function. Where is my cosine? Cosine is here. So, yep. Let's go here and let's go back here. Okay. Okay, where's my function? Oh, okay, again. Copy and paste. Right, we've got it. Very good. Right, lovely. Okay, I cannot make it bigger, but I can do it here. Okay, because we need to take a good look at the function. Right, so this is cosine. Look at that. This is cosine. It's very similar to sine, but the difference is just it doesn't start at 0, but it starts from 1 here. But we also have a period. So if I put here the line and at 2 pi, then you can see that here we have a period of the function, and the period is 2 pi. And then you have exactly the same wave. And what are we looking for is we want to see where the cosine is negative 1. So negative 1 is here. So let's take a look. Let me draw a line at this negative 1. And there we have something like that, right? And we can easily see that the angles which have cosine negative 1 is here, so it is pi, and then another one is 3 pi, and then probably 5 pi. So again, we need to look only in the period. We don't have to look beyond the period. So our answer is number pi, right? So the angle pi, and then we have to add our circle, our period, sorry. So 2k pi, where k, again, it's integer. Okay, so there you go. We have pi plus 2k pi. Yeah, it's really difficult to read this in English. And I'm sure I'm going to make just like huge amount of mistakes, but I hope that you will understand what I'm thinking about, and it will help some of you. So there you go. In Polish exam, we have matura exam in high school. We have special tables that you can use during your exam, and you have those functions. So our students can use those functions during the exam. That's why we like to use them and not really the circle. So there you go, right? We have pi plus 2k pi. So it's pi, 3 pi, 5 pi, so and so on. Right. Of course, the trigonometric equations are not that simple that you just can, just read from the function. They can be very complicated, as you probably assume. And I'm going to show you like one example that's going to be a bit more complicated. And the situation that you can come up or that you can come across is that you need to use some formulas. So there are many formulas that you might need to use during solving your trigonometric equations. I'm going to give you just a bunch, right? So of course, first of all, and like the most important, is this one. I'm sure you know it already. So sine squared plus cosine squared is always 1 for every angle. Whichever angle you just come up, even 100,000 degrees, it will be 1. So another one is sine of a double angle. And then this formula is 2 sine alpha cosine alpha. We also have a formula for double cosine, and then you have cosine squared alpha minus sine squared alpha. These are very common in equations. And then you have a big, huge bunch of formulas which gives you possibility to calculate, for example, sine alpha plus sine beta. Then you can subtract. Then you can calculate cosines. So you can do exactly the same with cosines. And so this is, and then we have subtraction. So this is another group. I am not going to give you all of them because, as I said, there's no much time for this video, but you can easily just look them up in the internet, right? So you can just write them down. And another group is for sine of the sum, right? I hope you see the difference. And the sine of subtraction, sorry. Then you have cosine of sum and cosine of subtraction. So you might come across some more difficult equations where you will need to use those formulas. Okay, so I will show you one of the equations where we can where we will use those formulas, just to show you how difficult they can be, right? Okay, so let me just look for this example and let's try and do something more difficult. Okay, right. Okay, for example, let's try this one. Solve the equation. Okay, and the equation looks like this. It's a cosine of a double angle. We use x here, okay? Sometimes you can use alpha, but you can easily find equations, trigonometric equations with x, where x is a real number, okay? And then we have cosine 2x plus cosine x plus 1 equals to 0. And we also have information that x is between 0 and 2 pi. So this is very important because if we know that x is only between 0 and 2 pi, then it's very good information for us because we don't need to go, to the infinity with the function. So we only look at the period between 0 and 2 pi, which is very much more easy for us. Okay, so let's take a look at the equation. It's not as easy as I showed you before, like sine x is 1/2, but it's not bad really. So as you can see here, we have the formula. Okay, I show you the formula that you can use for double angle. So we have double angle here. So let's use the formula, and it's going to be cosine x squared minus sinus x squared plus cosine x, so sorry, plus 1 equals to 0. Okay, and now at this moment we can't really do much, but we can get rid of one of the functions because we have cosine and sine, and it will be so much better if we have only one function. So let's substitute sine, because we have two cosines, so let's substitute sine by cosine by using this formula. It's very easy to do it with this formula, right? So instead of sine x, look here, we can put 1 minus cosine x squared. So that's what we're going to do. So let me just write this one, and now we have minus x plus cosine x plus 1 equals to 0. And how it helped us. So let's see. Plus cosine squared plus cosine x plus 1. Okay, so as you can see, negative 1 and positive 1 goes out, and we have 2 cosine squared x plus cosine x. And now what can we do? We can take one cosine and take it before the brackets, and then what we have left in the brackets is 2 cosine x plus 1, which is really good because we have multiplication, and multiplication which equals to 0 is always very good for us because we can then split it into two equations. Because it's very simple if you just ask yourself a question: when a product is 0, so only if one of the numbers is 0, right? That's the rule really of multiplication, is 0. So we can split this equation into two. So we can have cosine x is 0, or we use the symbol as or in mathematics, and the second one is 2 cosine x plus 1 equals to 0. And then you have two very simple equations. So first is cosine is 0, and the second is 2 cosine x equals really 2 minus 1, so cosine x equals to minus half. So we have these two simple equations, and now we have to go to the function, right? To the function, and find those x's, which gives us 0 and negative 1/2, and of course between 0 and 2 pi. So let me just put here number function again, cosine function, sorry, because we need this, right? So we will take a look here. Okay, okay, let me go back to the presentation. Right, and now let's take a look. First, we are looking for 0, right? So where is 0? 0 is here, and 0 is here. And where is our period? It's between 0 and 2 pi. So as you can see, we have 2 points which give us cosine x 0. So we have x equals to pi over 2, or x equals 3 pi over 2. Okay, great. Right, so that's the first part. And the second part, we need negative half. So let's see, where is negative half? So negative half will be here. So we have 2 points. One is here, and one is here, right? And then we don't have anything more. So the problem now is to just try to read which points are here. So you have to first just look which angle has 1/2. And of course we know that it is pi over 3. So it's 60 degrees, pi over 3. Okay? And cosine of 60 degrees is exactly 1/2. So if we go down below 0. So as you can see, it's the same length. So we have here, this point will be pi over 2 plus pi 3. Oh no, sorry, not pi 3. Okay, that will be a mistake. Pi over 6, of course, because 5 over 3 is the big part here, and this is the smallest part, which is pi over 6. So I have to take pi over 2 plus pi over 6, and then we have, let me just make a quick calculation. 3, is it 3 plus 1? It's 4/6 pi, right? So it's 2/3 pi. Okay, so there we go, the first point. And at this point, it's exactly the same length. So again, pi 6, but we have to just move to the left from 3 pi over 2. So, okay, let me just draw it here. And we have 3 pi over 2 minus pi over 6. Right, and let's find the common denominator. So it's 6. We have to multiply by 3, so it is 9 pi over 6 minus pi over 6. So we have 8/6 pi, which gives us 4 over 3 pi. Okay, so we have 2/3 and 4/3, and then we have 3 over 2.5. So let's write the answer. Okay, just all together. So the answer to our equation, we have 4 answers, right? Between 0 and between 2 pi. So we have, let me write it, all of them. Pi 2 then will be 2 over 3 pi. Then we will have 4/3 pi. And the last one is 3 halves of pi. 3 half pies. I really don't know how to read that. 3 halves pi, maybe something like this. Right, so these are our answers. So we have 1, 2, 3, 4 possibilities, 4 answers for these equations. So this is just one example to show you that trigonometric equations, they can get quite difficult sometimes, because you need to use all of those formulas, but always when you just try to solve them and try to simplify them by using these formulas, you will always get to the simplest one, right? So like this, so you will get multiplication, or you will get just one cosine or sine, and then what you have to do, you have to split the equations into 2, and then you have very simple equations which you will solve by looking at the functions, or eventually, if you prefer, you can look at the unit circle. Okay, thank you very much. This is just simple 3 examples just to show you how you can use functions. I hope it will help you a little bit with trigonometric equations. Thank you very much, and good luck with trigonometry.